All right. So we're going to talk about graphs. There's three types. All right, nice. There's three types of functions. We'll talk about sine, cosine, and tangent. And all of them look the same. You have A, enough. It might be hard to memorize these right now, but once we go through the graphs and you understand what A, B, H, K do, it actually will be pretty easy. So we'll start with A. Frank, stop. So you got your shout out right there. Okay. You win. A represents the amplitude. And I'm actually going to draw a general curve. So this right here is an example of a sine curve. And we'll actually plot the points. Well, yeah, if you rotate it. But what happens, if you were to plot the points, it would look like this. Cosine will be somewhat the same, but not quite. The amplitude, will be this. So it's simply the vertical distance. Yeah, I can always stop the video too, just so you know. You guys are no longer famous. Anyway, vertical distance from peak to the middle of the graph. Yeah. So that's amplitude. Amplitude is just it's like the height, but more specifically from the middle of the graph. When I say middle, of the line that would go right to the middle, or in this case, the x-axis. And Frank, do you want to sit outside and not be part of this? You can. Okay. And the peak. So that's the amplitude. And we'll see how this is incorporated into the graph a little later. B helps determine the period. And the period simply represents the length of one cycle. Mm-hmm. So this right here, bless you, that right there is considered the period. Because what do you think is going to happen if I were to continue the graph? Yeah, it will start repeating itself. Like if I, like I'm right over here, if I go up and down and so forth, or another way around, it's like over here, if I were to go up, down, or backwards, it would start repeating itself. So in that case, you have more than one cycle. Another way to think of it, wavelength, the length of one wave, right? Some of you guys have seen on chemistry. So the formula to find the period, because B is not the period. B helps determine the period. The period is actually going to be 2 pi divided by B. And that formula is used for both sine and cosine functions. And pi over B is used for tangent functions. You'll see why those formulas are the way they are when we start doing the examples. H and K, same as before. H represents the horizontal shift. We've talked about this before, like when we did parabolas, absolute value graphs, log graphs, exponential graphs, all that stuff. H represents the horizontal shift. Yep, K is vertical shift. We are not going to actually do any graphs with horizontal and vertical shifting today because this is the first time you're seeing sine, cosine, tangent. Over the weekend, the video of the weekend, you will see those kind of graphs and how they'll look. So today we're just going to look at ones where A and B can vary. And of course, we're going to look at how sine, cosine, tangent are when A and B are both 1, like the parent functions for both sine, cosine, tangent. So I think that's all I wanted to say. Just trying to think what I did with the other classes. Yeah, I think that's all I want to say for the first part. Okay. So now we'll do an example. We got 6 examples. They will take a while, and then we're going to do a little bit of graphing calculator work, and then we're done. Okay, first example, sine x. First time you ever see a function that you've never graphed before, I strongly recommend you guys make a table. Because if you do have a table, then it makes it easier to plot the points and then draw the graph. The other thing I'm going to do too, I'm going to pull up the unit circle. You don't have to pull it up. You could just look at the one I have over here. So we find it. Okay. So going back to number 1, graphing y equals sine x. What do you think are some good numbers to plug in for x? 0. And by the way, x is just like beta. So it's just an angle measure. So 0 is good. Because if you look at the unit circle, right, what coordinate do we reserve for sine? Y, right? So, and we see that sine of 0 is going to be 0, right? So that's kind of easy to work with. What do you think is another good value to plug in for x? 90 degrees or pi over 2. Yeah, actually that's another great point that we need to bring up. Helps to be great question. The reason why is because if you were in degrees, what's going to happen is that when you make your tick marks on the x-axis, you're actually going from 0 to 360. So you'd be doing like a ridiculous amount of tick marks. And it'd just be too big. That's the reason why. We keep it in radians. So pi over 2, and what's sine pi over 2? When we're at the end, we do the calculated work. 1, okay. What's another good one to plug in? We could do that, but let's do pi. Because if you think about it, right now, sine of 0 is 0, right? Then when you go to pi over 2, what's sine of pi over 2? 1. Now if you keep going, what happens to the sine values as you keep going? They get small until you hit 0. And then what happens to the y coordinates again? They keep getting small until you get to, then they start rising back again to 0. So when you go around the whole circle, you've covered all y values, right? That's what helps to know the unit circle to do this stuff. If you start here, you're at y is 0, y is 1, 0, negative 1, and back to 0. So you've covered all the positive and negative y values on the unit circle when you go from 0 to 2 pi. So obviously, sine of pi is 0. What's sine of 3 pi over 2? And sine of 2 pi? 0. You don't have to use these. They just make it easier because now we can see the highest point and the lowest point, and also when it crosses the x-axis. And those are usually pretty significant points because you want high, low, and x-intercepts. So when you graph it, you want to make 5 tick marks. The first one at 0, the last one at 2 pi, and then 3 in between. What do I put right smack in the middle? Pi. Then pi over 2, and 3 pi over 2. And the y coordinates are 1 and negative 1. Okay, let's make the graph. So those are your points, and you just connect them. That's all. So that's how that would look. And if you wanted to keep going, it would just be like this. Now it'll stay the same. I just did a crappy job of drawing the curves. But they'd stay the same. But this right here, we'll change colors. Go back, let's try blue. See how that's your period? 2 pi. And see how that's your amplitude? 1. Once you get really good at these, you don't really have to make a table. You can just identify what A and B are and just work it out. So if we look at number 1, what is A for that? 1, right? Because going back up here, A is the number to the left of sine, and B is the number to the left of x. So if you don't see numbers there, you always assume it's 1. And so if A is 1, because we don't see a number being multiplied with sine, so we assume it's 1, what's B going to be here? 1 as well, right? So if A is 1, that means that the amplitude is 1. If B is 1, what's the period going to equal? 2 pi. Because we're in the formulas 2 pi over D. Well, do you see why B is 1? Exactly. And do you see why B is 1? Because that's a coefficient for x. And you don't see a coefficient, so you assume it's 1. Right? Well, what's the coefficient for x here? Just 1, right? Yeah, you're just doing sine of x. You're not doing sine of 2x or 5x or whatever. Just doing sine of x. And again, going back to the unit circle, when you go from 0 to 2 pi, that covers all possible sine values. So nothing's ignored, neglected. Everything's covered. Another way to think about it too, it's almost like unwrapping the unit circle. It's almost like if you were to cut the unit circle and there's like a piece of string, and then kind of like, I don't know, readjust it so it follows this curve. So that's essentially what we're doing. It's like we're going around the unit circle and picking all the y values to help generate this curve. I think that's all I wanted to say about that one. Oh, yeah, a few other things I need to say too. Forgot. Oh, there we go. We'll call this the peak. We'll call that the trough. Not a very sophisticated name, but you know, like the peak's the highest point, trough's the lowest point. And I'm going to draw a dashed line through the middle. I'm going to call that the midline. If you ask a math teacher, like, you know, what is the midline, they'll have no idea what you're talking about. It's a term I made up, but it's just a line that goes right to the middle of the graph. In this case, it happens to coincide with the x-axis, but when we start shifting the graphs up and down, of course, the midline will change. I like to just have some name for that, so when we start shifting graphs, it makes it easy for you to understand how the shifting's happening. Any questions about number 1 so far? No? All right. Okay, let's move on to number 2. How will number 2 be different than number 1? So how's the change graph? No, it'll be twice as big. Think about it. You guys heard of like an amplifier? Like stereo. What does the amplifier do? Louder. And sound can be characterized by waves, right? So it just makes the sound wave larger, right? Which obviously makes the noise louder. So really, we don't have to waste time making a table. We can do this more quickly. A equals 2. B equals 1. Amplitude is 2. And the period is still 2 pi. Now the period's important to know because this will help you determine when to start the graph, where to start the graph and where to end the graph. Now we haven't done any horizontal shifting yet, so we don't have to worry about starting at another place besides 0. So the starting place will be 0 for x. and ending point will be 2 pi, because again, the period is 2 pi. So you put 0 and 2 pi here. What was that? Oh, they keep going. We're just only doing one cycle, though. Yeah, it's the easiest cycle to graph. But yeah, you're right. They keep going. And they're called periodic functions for a good reason, because they're repeating themselves. So the middle is pi, then pi over 2, and then 3 pi over 2. And the amplitude is 2. So when I do the plot, where do I start again? Right, because sine 0 is 0, so just because I'm doing 2 sine 0, it's not any different. 2 times 0 is still 0. But when I plug in pi over 2, now what's the y value? It's 2 exactly. Then when I do pi, it comes back down to, what, 0. Then it keeps going down to, and then back to, so that's how the graph looks. So you can see the difference between that one and the original graph. Period, stays the same, but amplitude is obviously different. Okay, any questions so far about that one? No? All right. I'm going to stop the video and make a new one.